Hey guys, today we're talking about graphs and relations, and I'm on page 46. So follow along in the textbook. Number 1, it says explain why the order of the numbers in an ordered pair is important. So the numbers in an ordered pair are important because the first number is always the x value and tells us to move along the x-axis. And the second value is always the y value, which tells us to move up or down. And that's why the order is important. Number 2 says describe the difference between dependent and independent variables. So this is something new that I want to teach you. So independent variables are almost always the x values when you're reading a bunch of values. Okay? I'm going to erase a little bit. Okay. So they are the x values, and the dependent variables, I'm sure you can guess, are your y values. And it's just like it sounds. The independent variables don't rely on anything. They kind of stand alone. They're independent. The dependent variables depend on the independent ones, on the x ones. So they're affected by the x's. Okay? So the dependent are the y values. Number 3 says give an example of a relation, identify the domain and range. So a relation is just a set of ordered pairs that go together. So I could come up with any set of ordered pairs. Okay, there's my ordered pairs, and when they are a relation, you're going to see them inside of these little squiggly bars, which are called solution set bars. Okay, so this is my relation because it's a set of ordered pairs that belong together, and it's usually describing some kind of data. And then it says to identify the domain and range of each one. So remember from last year, domain are all your x values, and the range is all your y values. So let's go ahead and list those for this relation that I just wrote up top. So my domains are all my x's. So all I'm going to do is write them with commas in between. And then I'm going to put those little solution set bars on the outside. And that's my domain, all the x's. To list the range, we're going to do the same with our y's. So I'm going to separate them with a comma and then put my little solution set bars on them as well. Okay? So the next one, number 4, says the graph at the right represents Alexi's speed as he rides his bike. Give a description of what is happening in the graph. So a description of what might be happening as Alexi rides his bike, according to this graph, is there's a couple of different things I can think of. Number 1, he's riding on hills, which is causing his speed to speed up and slow down, and speed up and slow down, whether he's going uphill or downhill. Another thing that might be happening is he's riding through town. Maybe there's a busy town and there's a lot of stoplights, and he has to keep stopping and wait for a light to change, and then he can go again. So that causes his speed to go up and then down, and then up and then down. Okay, so that's all you're doing on number 4 is just kind of interpreting that graph and trying to figure out what's going on according to the picture. Number 5 says identify the graph that represents the height of a skydiver just before she jumps from a plane all the way until she lands. Okay, so we have these 3 different graphs to choose from. Which one shows the height of a skydiver from when she jumps out of the plane till she lands? So we're talking about height on the side that's going up and down and time across the bottom. So I need to look for how high would a skydiver be when she jumps? Is she going to be down here and get higher after she jumps out of the plane? Probably not. Is she going to be here on this last graph and continually get higher as she jumps out of a plane? Probably not, unless she's in outer space, which she's not. Or is she going to start high up here and gradually go down to the ground? Most likely. So the graph that most likely looks like the skydiver jumping out of the airplane is the middle one, graph B. Okay, for 6 through 8, it says use the table and the information. During an experiment, the students of Mrs. Roswell's class recorded the height of an object above the ground at several intervals after it was dropped from a height of 5 meters. The results are in the table below. Notice in the table we have time and height. So let's talk about that. Time is on top of this table and height is the second row. IGHT. Okay. So that means time is my x values, my domain, and y is my height or my range. Okay? So in tables like this, you're always going to see x along the top, y along the bottom. And x, as you remember from before, is your independent variable, and y is going to be your dependent variable. Whatever y does depends on what x does. So number 6 says identify the independent and dependent variables. So independent variable would be time, that's my x value, and the dependent variable would be the height. Number 7, write a set of ordered pairs representing the data in the table. So all you're going to do is remember, if this is x and this is y, I'm going to take each of those and write them together as an ordered pair. So I'm just reading from the chart in the book right now. And I'm going to write these ordered pairs. The first one would be 0, 500. Then I have 0.2 and 480. Then I have 0.4 and 422. I have 0.6 and 324, 0.8 and 186, and last I have 1 and 10. So remember, x values is all of my time, how long it took for it to happen, and the y value is all of my height, how high it was up. So let's keep going. That was number 7. Number 8. Draw a graph showing the relationship between the height of a falling object and the time. So for the draw a graph part, okay, so I drew this graph so you didn't have to watch me draw the whole thing. And what I'm going to do is I'm going to take all those ordered pairs from the table in the book and I'm going to plot them on this chart that I made, this graph. So along the bottom, you'll notice I put time, and I'm sorry it's a little bit messy because I'm using this stylus and it's tricky. But I put all my times across the bottom, 0.2, 0.4, 0.6, 0.8, and 1. And then going up is my height. And I just counted by hundreds because there is a large difference in the numbers that I have, so I want to make sure I can fit them all on this graph. Okay, so I'm just going to start by plotting the first ordered pair. 0, which means I don't move right at all, and 500. So there's my first one, 0, 500. And remember, when you plot points, you have to label them. The next one is 0.2 and 480, which would be right around there. Oh my goodness, this pen is not cooperating. Sorry. And the next one is going to be 0.4 and 422. So right about there. Then I have 0.6 and 324. And I have 0.8 and 126. 186, sorry. And last, I have 1 and 10. So 1 and 10. Okay, and that's all there is to it. Just graphing my ordered pairs. Now remember, this chart was something that was being dropped, an object that the students were dropping. And so it would make sense that they would start out high and then go down low and finish low on the ground, most likely, as time went on. So as time goes on, they start high, a little bit of time has passed, but the more time that passes, sorry, it's late and I'm tired. The more time that passes, it gets lower and lower to the ground. Okay? And that's all for my examples for this lesson. So please take notes, watch again if you need to, and email me if you have any questions. I will see you next time.